Okay, we're going to take a look at a homework problem here and go through the solution. In this particular homework problem, we're giving the formula for a PDF, a probability density function, and we want to compute, well, we're not going to actually compute the formula for the CDF, but we're going to get the calculator to graph the CDF for us. And then we're going to use the CDF and or the PDF to answer some probability questions. So the first thing we want to do is put our PDF in the calculator. Now, the instructions here say to put it in Y1, and you can follow the instructions and do this perfectly. But if you remember from our video earlier, there's a little bit better way to do it. I've already got the appropriate things set up in Y6, and we'll review this in just a minute. But it requires that the PDF goes in Y7, so I'm going to put the formula in Y7 instead. So I've got it started here, 1.84 e to the power, and then that's negative 1.84x, close parentheses. Then what we want to do to get the formula for the CDF, or not the formula, but the graph for it, what we want to do is to, well, let's just remember that when we, well, let's just graph this to start with. This particular one only applies from 0 on to the right, so positive and 0 for x, but no negatives. So technically it's 0 for negatives, but we can ignore all the negatives completely. So when I set my window up, I need to start it at 0, and then I need to go to the right. Well, technically it goes on to infinity, but it's going to come down and get really close to the x-axis very quickly, so we don't have to go out very far. I think 20 might be alright. We'll try it out. And I'm going to just leave this set up like this. This is a pretty good setup for a CDF from negative 0.2 to 1.1 for y, going up by 0.1. And since we're eventually going to get the CDF graph, I'm going to leave that as well. So this gives us a graph, and it starts up here and comes down. It actually starts at 1.84 on the y-axis, and then comes down from there. Actually, you know, we maybe want to go a little bit higher to be able to pick up that. So if we go up to maybe 1.9, we can actually see the top of this coming down. And really 20 is too far to go out, or it's not, we don't need to go out that far. So I'm going to actually go out to only about 10, and I think that's going to give me what I need. Okay, so anyway, there's a decent looking graph there of the PDF. Now remember that the CDF represents a cumulative area. So if we, for example, if we want to go down here and do number 2, the probability x is less than 8, we can do it from the PDF by doing calculate, second trace, and go to number 7, which is an integral or calculation of an area, and we want to go from 0, which is the lower limit, up to 8, and type that in. And so it goes up to there. It only goes up to 8. Actually, this is 10. Out here it's shading to right here to 8. And we're nearly all the way full up at 1 there, 0.99999. That's enough 9s that we round this off to 4 decimal places, which it asked for. It's actually just going to be 1.40s. Okay. If I did another one, let's say I want to clear this drawing, so that'll clear out this. Let me just do something shorter, like just go to 1. So I can do the same thing here and calculate this from 0 to 1, and it only shades up to there. Now this area is that probability that x is less than 1. That's also the y value of the PDF. So the PDF right here, if I go straight up from here, this, with this same x value of 1, and put a y value of 0.84, this is almost 2 here, so somebody right about in the middle, right there about is going to be the dot for the CDF. So the CDF is a cumulative area, and this numerical integral thing, FNINT, computes this area. So look what this says we're going to do. We're going to take our function, our Y7 function, which is the PDF. This is always x for the second one, and we're going to go from some lower limit up to x. Now we need to put in the value for the lower limit so that there is zero probability below, and that this formula applies from there on. So in our case, L is 0. So I could actually replace that L with the 0, or if I want, I can just take 0 and store it as L. Notice alpha L is, the store button is right down here. L is this above the parentheses here, so I can store that as 0. Or like I said again, I could have actually just typed the 0 in there. Now some of you are saying, well, my calculator doesn't look like this. Okay, if you've got the newer operating system, you can toggle this on and off the way it looks by going down here, and there's more down here. Keep going. And we get down here to here, and we can go to Math Print. If I do that and quit, now when I go back here, you can see the way it's going to look in your calculator. And that is the way you would actually more write it. So we're going from the lower limit of 0, so that might be either 0 or L there. We're going up to x. This is always x at the end here, dx, and this is y7. So it's still the same 4 inputs. The order for the function integrate is this one first in the parentheses, then this x at the end, then the one at the lower, and then the upper. But this is a little easier to keep track of. This long S here stands for summing up areas. This L at the bottom is our lower limit. The X is the upper limit. So we're going from L up to X. This is what the PDF that we're finding the area under. And this X is just telling us that's our variable. And notice this also gives us a nicer looking thing down here for the exponent. So we're going to look at that. And if I toggle that on now, by going to here, I've also made it a little thicker here. So now when I graph it, it's going to graph the CDF. Now this may graph a little bit more slowly than the others because it's using approximation techniques to find this out, to compute these values. Now what does a CDF always do? It always starts at 0 and ends at 1. So if you notice, this one technically never really reaches 1, it has an asymptote of 1, but it gets, for all practical purposes, it gets there. And so this is going from 0 up and leveling off at 1. While that's working out over there, I'm going to come over here and go, the CDF of 0 is 0, and if you do it this way here, you notice that this part is 0 here, and so it can be just ignored. So basically it's the same thing. Now if we want to know the probability that x is greater than 10, we have a couple of different options. Okay, so notice that the probability that x is greater than 10 is 1 minus the probability that x is less than or equal to 10. Well, this is CDF of 10. So I can actually, since I have the CDF almost graph there, I can go in and use this to either trace and find the value of the CDF, or I can actually basically type this. It's in y6, so I can type in 1 minus y6 of 10 in my home screen. So we'll do it there. Okay, so let's go ahead and do it that way. All right, so let's go to the home screen, and I can do 1 minus. Now if you've got the newer operating system, you can go alpha here to get y whatever. In this case it's y6, I believe. And we can say of 10. And that's going to be the probability that we're getting. And it's practically 0. That's times 10 to the negative 8. So it's 0.7 zeros and a 1. So to 4 decimal places, this is just 0. Or just type 0. Kind of poor choices there for the numbers. Okay. We can also do it on the graph by going to the graph here and just shading from 10 on out to the right. Of course, there is basically there's nothing there. There's very little there. So let's go on to the next one, between 6 and 11. So we can do it from the PDF by calculating this. I can even shade it. Number 7, 6 to 11. I need to get on the right curve. I need to do 6 and 11, and I think this is going to give me a problem because it's off screen. Yeah. So I need to change my screen a little bit to go out at least to 11. Oh, let's go out to 12. Because I got to get 11 in there. Okay, so this is going to graph. It's going to take a second. So while it's doing that, let's look here. So we can look at it two different ways. We can basically look at the graph. Here's a graph kind of like this, a rough sketch. Somewhere in here is 6, somewhere out here is 11. This is definitely closer to the axis than that. But we're looking at an area like that we're shading, and this is under the PDF. Okay, so this is probably the X is between 6 and 11 is the area under there. But we can also look at it from the CDF. So the CDF, remember, looks something like this. That 0 there. And if we look at 11 here, it's practically at 1. So this would be CDF of 11, which is the probability that X is less than 11. See, that would be from here down on the graph. That would be all the way to here. But then we need to subtract off this part here, which is the probability that X is less than 6. Well, this one is CDF of 11, and this one is CDF of 6. So we can actually do Y6 of 11 minus Y6 of 6. I'm going to do this one at the home screen. On the picture here, somewhere in here is 6. I'm sorry. Somewhere in here is 6. Okay, and we get CDF of 6 here. And the distance right here between these two, this vertical distance, that is this probability. Okay, so let's go back here, and just to make sure we understand this, let's look at if we just want to do the probability that X is less than 6. We could see that by doing shading here, getting under the PDF and going from 0 to 6. Okay, and it shades out here to 6. It's still practically 1. Let me get something short, smaller than that. Let's say, just to illustrate, so probability that X is less than 2. Okay, so I'm going to clear the screen. Okay, it's going to take a minute to draw again. So what this is going to do, this is going to give me a graph like this between 0 and 2. But it's also going to be the Y value right here of the CDF. This is PDF. So the CDF here, okay, the Y values are cumulative probabilities. The PDF areas are probabilities. Okay, I'm not going to worry about that right now. Let's go ahead and I'm going to quit this. Go to the home screen. Okay, and let's go back and figure this probability here from the home screen. Now, since I have the CDF and Y6, let me show you how to get Y6 if you don't have the newer operating system. You go to Variables, right arrow to Y Variables, choose Function, and then it's number 6. So Y6 of 11 minus Y6. Here's a way to get it if you have the newer operating system. Actually, you can still do it the other way on the newer operating system, but you also have this extra way of doing it. And this will give us our probability, which is pretty small. Yeah, still practically 0. 0.4 zeros and a 1. This is still practically 0. Okay. Now, what about this here? Now, notice that questions 2, 3, and 4 we could have done from either the PDF or the CDF. We had multiple ways of doing it now. But question 5 and 6 require us to use the CDF. So in fact, I'm going to go down here and to avoid a little confusion, I'm going to turn off the Y7. Now, I can't, if I clear out Y7, then Y6 won't work right. But if I do this, it will graph Y6. Now, what I also want to do is I want to graph a horizontal line at this particular probability, 0.9958. So what I'm doing is I'm looking at this graph, and I want to know the cumulative probability. I know the probability, I just don't know the x value that goes with that. So this is an inverse probability problem. So in this inverse probability, what we need to do is we need to we're given a y, and we need to find the x that goes with it on this graph. So the way to do that on the calculator is to graph a horizontal line at that particular y, and then we just calculate the intersection of these two graphs. Again, this is a bit slow, so you do have to wait for it just a little bit. The reason this is so slow is because it's doing some approximation techniques in calculating this. It's doing a whole bunch of calculations to get every single point, probably hundreds. So it's just, even as fast as a calculator is, it's still a little bit slow pulling this up. But hopefully not too slow to be able to work on an exam or something like that. The horizontal line will graph much faster, and we're almost done with this one, and then the horizontal line will come in. And then we want to calculate, there's the horizontal line. It's really hard to tell where they cross because they're so close together for such a long time there. But we can still use the calculator to do that, so we can say calculate second trace, and we're going to calculate an intersection, which is number 5, so I just press 5. First curve, now make sure you go on the right thing. If you still have the PDF graphed here, you'd have 3 curves, and you'd have to make sure you're on the right one. First curve is the Y6, which is the CDF, so that's good. Now I'm on the other one. If you need to go up and down between the curves, hit the up or down button. Just keep hitting the same one, up or down, until it gets to the curve that you want. Here's the one I want, the constant, so I hit enter. And then there my guess. This is good enough, I guess. And let's see what we get here. Take it a second here. Okay, and so 0.9958 is the y, as we knew, and there's the x, and that x is the c value here, 2.9743, if you round off to 4 decimal places, and I think that's what the directions say. Now the median of the distribution is an x value. It's the same kind of problem we just had. It's an x value where half the probability is below. So remember, the probability that x is less than or equal to the median is 0.5. So this is exactly the same kind of question that we just did. We just want to change this value that's down here in Y7 to 0.5. Okay, and again, where we're going to calculate an intersection there. It's going to have to draw them again. So here we go, waiting on that thing to draw again. Okay, so while we're waiting on that, let's come back here. When this calculates, the x value that we find will be the one that we're looking for. Now the mean of the distribution, let's talk about that. The mean, of course, is denoted by mu. Remember, that's the expected value of x. Remember, in a discrete case, this would have been equal to, you take the x value times the probability of x, the PDF of x, and you add it up for all x's. Well, in a continuous case, it's going to be the same thing. You take the x value times the PDF formula, and you add it up over all x's. Okay? So, in our particular case, all x's go from 0 to infinity, and we take x, our PDF is in y7, like that. Now the problem is we can't actually put in infinity in these calculators, but I think we've already seen that really by the time you got up about, well, even by 12 we were practically all the way there. So I'd say 20 is going to be plenty good enough, because going past 20, there's basically nothing there anyway. So we can go with this. Alright, looks like our calculator is ready to go here. So let's go back here. First curve, enter. Second curve, enter. And the guess is way back here. Let me just type in 1. I think that's going to be pretty close. And then let's go ahead and see what it comes up with. Okay, and it's actually 0.3 something, so 0.3767. Okay, so let's do the mean. The mean we need to do from the home screen. We don't need to graph this. So we do math 9. Okay, and this goes from our lower limit of 0. Our upper limit is, well, really it's infinity, but 20 is going to be good enough for us. We want to put the PDF, well, we don't do x times the PDF. So we want to do x times the PDF. By the way, before I do that, let me just do this. What if I just put the PDF in there only? No x with it. That was y7, I believe. We should get the total area here, which this should work out to be 1. Okay, and that kind of tells us we're far enough out. So now if I take my previous thing here and just go back to this and insert an x times, this will compute the mean. .5435, we round off to 4 places. Now, by the way, what does this look like if you have the older operating system? I could go here and turn this back to classic. Quit. I like the newer version better. I think it's actually easier to keep track. And if I do the second entry, there's exactly what it looks like with the old version of the calculator. Same exact thing. Now the variance sigma square is the expected value of x minus mu square. Now remember how we did this in the discrete case? We took the x's, subtracted the mean, squared them, multiplied by the probability, and then added them up for all x. Well, in the continuous case, we're going to do the same thing. We're going to take x minus the mean, okay, square it, multiply by the PDF, and add that up over all x's, like that. So in our case, that's going to go from 0 to infinity, x minus the mean. Well, I don't want to have to type all those digits again, so I'm going to store this as m. So over here in the calculator, I'm going to hit store alpha m. So I know the mean is in m, so I don't have to type these digits again. PDF is in Y7. And so we just enter it like that in the new version. In this version here, I can go to Math 9. Okay. Parentheses. Whoops, I've got to need a square over here. Over here it is x minus the mean, which is m, parentheses, square that, times variables, y variables, function, and I've got it in 7, y7, comma, always an x here, comma, lowest x possible, 0, highest x possible, well, it should be infinity. We're going to do 20 is going to be close enough. Enter. And that's going to give us our variance. Okay? And again, if it looks on the new version, this is what it looks like. Looks pretty much just like you write it by hand. Again, the four things, 0, 20, x minus the mean square times the PDF function. Of course, this is always dx at the end. Gives you the same answer again. So the variance is 0.2954. And of course, you just take the square root of that, square root of our answer, to find the standard deviation. Okay, so that gives you a pretty good idea and an overview of how we can use the calculator. I showed you the newer version of the operating system, also the older version. We were able to see how we were able to take the formula for the PDF, put it in this case in Y7. We use this notation here to put in for Y6, and Y6 then will be the CDF that goes with that PDF that's in Y7. You do need to store the appropriate number in L, either retype the number in there or store something as L. And that's the number so that there's 0 below it, or at least practically 0 below it. And so that's going to be, in this case, 0. And this formula starts taking over at 0. You can leave this set up in Y6, and so the only thing you have to do is change L, and you can go up here and toggle it on or off by putting your cursor on the equals, hit enter, and now it's not going to graph anything or do anything with Y6 until we turn it back on. Alright, hopefully that's a bit of a help. And notice it really didn't matter what this formula was in Y7, as long as we can type that formula in there, and as long as it's a legitimate PDF formula, everything's going to work out fine, and we can work these problems the same way. So you have several problems that are like this with different formulas here.